Hello viewers, today I am discussing core type transformer construction. So this is the general view of the transformer. This is core and this is primary winding and this is secondary winding. So primary winding is nothing but more number of turns are there. Secondary winding less number of turns are there. This is nothing but HV, this is nothing but LV. So the winding procedure of the core type is called as interleaved and concentric winding procedure. So, so what is the interleaved winding? What is concentric winding? I will explain in further. So now, so if we place the total primary winding in one limb, if total secondary winding, if we place on one limb, what will be the problem? So if you place this winding like this, the flux which will generate, which will produced by the primary winding can flow in the core, and also some of the flux will leakage. So some of the flux may go outside. So if the flux go outside, those flux are called leakage flux. In the similarly in the secondary winding also same thing will happen. Some of the flux of secondary winding may go outside. So the outside flux, whatever the flux will leave outside, those flux are called leakage flux. So if the flux leakage takes place, so what will be the problem? If the flux leakage increases, if the flux leakage increases, then the power transfer from one circuit to, that is the primary to secondary, is decreases. If the power transfer decreases, then the transformer efficiency decreases. This is the most important concept. And so to overcome that problem, to overcome the leakage flux, we have a method, we have a procedure of placing the winding on primary and secondary uh, limbs. So, what is interleaved winding? First of all, let us discuss that one. What is interleaved winding? So, interleaved winding is nothing but, for example, I am taking primary has 200 tons. Primary has 200 tons and secondary has 100 tons. Because the primary is having more number of tons, that's why I took 200, and the secondary is having less number of tons, so that I took 100 tons. So these 200 tons I have divided into two parts, 100 plus 100. Similarly, secondary 100 tons also I divided 50 plus 50. So, so interleaved winding procedure is nothing but 100 tons of primary HV tons placed on one limb like this, and like this, and the remaining 100, remaining these 100 of primary HV turns placed on secondary side, nothing but other limbs like this. And after that, other the terminal can be taken as primary side, and this is nothing but V1, nothing but primary winding. So the total 200 tons, nothing but total HV tons divided into two groups. First group is 100 tons placed on one limb, and the remaining 100 tons placed on another limb. So similarly, secondary 100 tons out of 100, 50 tons, 50 tons placed on secondary like this, 50 tons placed on secondary, and the remaining 50 tons placed on primary like this. And this terminal can be taken as outside, and this is nothing but V2. This terminal is nothing but V2. So interleaved winding is nothing but dividing the total turns into two parts and placing the two parts in different places. Nothing but first part is on one limb and the second part is on other limbs. This procedure is called interleaved winding. This procedure called interleaved winding procedure. So now the primary is having both HV and LV. Similarly, secondary is also having HV and LV. So this is nothing but interleaved winding. Next, what is concentric winding procedure? So let us discuss that one. What is concentric winding procedure? So concentric winding procedure is nothing but placing the winding one after another. So here HV turns 100 are there, LV turns 50 are there. So generally here, first of all, we should place LV turns. Over that one, we should place HV turns. Such a procedure is called concentric winding procedure. So how it will be, I will explain now. So if you saw the concentric winding procedure, look at this one. So this is nothing but first this is core, this is core, this is nothing but a LV winding, and over that one HV winding is there. This is nothing but LV winding. So outer one is nothing but HV winding. So if we cut this total part, that will appear like this, that will appear like this. So this is nothing but LV, this is nothing but HV. This is first one is near to the core is LV, and after that one HV is there. So this procedure, this view I represented here, I represented that view. So I represented here. So this is nothing but first of all primary is having both LV and HV, and so look at this one, this is core, this is core, and after the core, before placing LV winding around the core, we should place the insulation between LV winding and core. So why we should place the insulation? Because core is nothing but a conducting material, so that LV also conducting material. If both are connected without any insulation between these two, then what will happen? Both will be short circuited, and the total core will be act as a conductor. So that we should place the insulation between LV and core. So, so how to select the insulation between LV and core? So, insulation capacity, how much capacity insulation we should place? So that there is a the formula is there, but insulation formula. So insulation requirement is equal to voltage capacity of LV minus voltage capacity of core. So voltage capacity, nothing but the voltage capacity of LV I assumed. So this is nothing but HV. Primary is having more number of turns. So I'm taking 33 by 11 kV. So primary is having 33 kV and secondary is having 11 kV. So because as per the 200 turns are there, so that more turns, so that 33 kV. At secondary side 100 turns are there, so that nothing but less turns. So that I am taking for example secondary is having 11 kV. So I assumed LV as 11 kV, so that LV voltage is nothing but 11 kV minus voltage of the core. So this voltage of the core is 0. We are not applying any voltage to the core directly, so that 0 volts, the total will be 11 kV. 11 kV. So insulation is 11 kV insulation we should place between LV and core, LV and core. And after the insulation, we should do surround the winding. We should surround the winding, and this winding is nothing but LV is nothing but more cross section area and less number of turn. More cross section area and less number of turns. The flux which will generate in the LV winding, so these flux which will generate in the LV winding, those flux can flow in the core, and remaining, if any leakage flux takes place like this, leakage flux links with the HV winding. So how to place the HV winding? Let us discuss that one. So after placing LV winding, we should place insulation. After that we should place the HV winding. So This is the same formula we should use for the placement of this insulation. So insulation formula is nothing but we should place the insulation based on this formula. Insulation requirement is nothing but voltage at HV winding and voltage at LV winding. LV winding. The difference between HV winding and LV winding, the difference between LV and HV winding, such a amount of insulation we should place between LV and HV. So HV is nothing but how much? 33 kV, LV 11 kV. Difference is 22. So 22 kV insulation we should place between HV and LV. So after the insulation, we should surround the HV winding. We should surround the HV winding. So this is the procedure of placing winding one on another. So we are concentrating total winding at a particular place. So that winding procedure is called concentric winding procedure. Concentric winding procedure. Concentric winding procedure. So if we use such a procedure, we can reduce the leakage flux. Whatever the leakage flux takes place due to LV winding, those flux will link with the HV winding. So if the if any leakage flux takes place in the HV winding outer side, there is no chance to use this leakage flux. So this problem can be avoided with the core type transformer, because winding is surrounded by the shell type transformer. Winding is surrounded by the core, so that in shell type transformer these leakage flux also utilized, so that power transfer capability is more in shell type transformer compared to the core type transformer. So this is the procedure of the concentric winding procedure and interleaved winding procedure. These two procedures are used in the core type transformer construction. So fine, everything is completed, but the final one point is there. One point is there. That is, if we place if we place HV winding nearer to the core, what will be the problem? If we place HV winding, what will be the problem? If we place HV winding, the problem is insulation requirement. Insulation requirement is nothing but difference between HV winding minus core. So HV capacity is 33 kV and LV capacity, core capacity is 0 volts. The difference is 33 kV insulation is required between, if you place HV nearer to the core, HV and core 33 kV insulation is required. If the 33 kV insulation is nothing but large size of insulation, if you place insulation nearer to the core, the diameter of the core increases like this one. So the diameter of the core increases. If the diameter increases, and after that we should place the LV winding. LV winding circumference increases. After that we should place the LV winding. Between LV and HP again we should place the insulation, and the insulation diameter also increases. Insulation circumference increases. After that one we should place LV winding. LV winding circumference increases. LV winding diameter also increases. So that due to placing of HV winding nearer to the core, problems are insulation increases, copper nothing but winding increases. Due to these two, weight, cost and space of the transformer increases. So to avoid these problems, we should place LV winding nearer to the core. So this is the complete construction of core type transformer. Thank you for